myself, Mari-Carmen Pineda, working for C2O Consulting. That name was very easy. And I'm going to present on reducing end-of-catchment fine sediment loads and ecosystem impacts. It's a synthesis, another one of the synthesis topics. Jane Waterhouse presented the one on nutrients this morning, and I'm moving now towards the one in, oh, it's not there yet. Should I give one more? Okay. Oh, okay. Yeah. And I'm going to present the one on sediments. Well, first of all, I guess that this slide is a bit pointless at the moment because we've been talking about sediments for nearly the whole day. But why was there a need for a sediment theme? We are all very aware now that declining water quality from the adjacent catchment is one of the major causes of current poor state of many ecosystems within the Great Barrier Reef, and that improving that water quality has an important role in building that ecosystem resilience. We've also heard in several presentations that fine sediments specifically are the ones posing a risk to the Great Barrier Reef, coastal and marine ecosystems through different pathways, such as reducing the light available for benthic organisms, including seagrass and coral. Approximately 10,000 kilotons of fine sediments, silt and clay, are delivered every year to the Great Barrier Reef. And grazing lands are some of the dominant land uses contributing to this sediment, depending on the catchments, but overall. There's been some progress towards the Reef 2050 water quality targets, but it's been slow. Therefore, there's a need for management options that are cost-effective and target. And for that, we need to continually improve our knowledge and ability to select the most appropriate solutions. And this is what this synthesis topic is aiming to do. The NESP TWQ Water Quality Hub Research on sediments overall focus on the source, transport, fate, and impact of sediments on estuarine, coastal, and reef ecosystems. And this included a refined understanding of the sediment dynamics from catchment to reef. It has also examined where sediment disperses in the marine environment and how to monitor, measure, and report on its dispersion. Some projects have also done some simulation of the changes to environmental conditions as a result of sediment inputs and its implications for seagrass communities. Using tracing techniques, there's also been investigations of the most environmentally relevant sediment characteristics and sources. There's been also investigation and trials of remediation methods for gully and streamback erosion, and some techniques have been developed for measurement and evaluation of water quality outcomes. As Jane showed this morning, the synthesis projects consist of a technical synthesis report, which will be hopefully finished very soon, and you'll be able to access to it through the website, the interactive website, and some case studies to do a bit more in-depth research on subtopics. Just very briefly, the case studies for the sediment topic were the effect of catchment land management on seagrass habitat in the Great Barrier Reef, where Barbara Robson from AIMS and Catherine Collier from JCU combined tools and learnings to assess the seagrass species distributions under different end-of-catchment load scenarios and the influence of this on benthic light. Results have shown that, indeed, improving land management practices would increase the area of suitable seagrass habitat and improve the quality of existing habitats for both shallow water and deep water species. A second case study focused on the importance of the sediment composition for the Great Barrier Reef ecosystems. As Steve Lewis and Zoe Benbridge from Tropwater presented before, they have presented a refined understanding of the most important characteristics of land-derived sediment and particulate nutrients, focusing on relevance to future management priorities. And the results, as we've seen as well, have shown that it's the fine grain, those sediments under 20 micron size, which is also organic rich, that has the highest impact on marine ecosystems through both direct effects, such as smothering, and the increased reduction of benthic light. And a third case study between Rebecca Bartley from CSIRO and Andrew Brooks from Griffith University has prepared the lessons for gully management. It's an accessible summary of the key findings relevant to current and future gully management projects. This case study incorporates transferable learnings associated with gully characterization, site selection, treatments, monitoring, and evaluation. I'm going to summarize very briefly some of the highlights for this topic, and we're starting on the reef side of our story. We're going to talk about the sediment fate and impacts in the Great Barrier Reef. NESP results have shown how flood plume sediments can cause increased suppression of light in shallow turbid environments, as Steve presented before, influencing inshore coral reef sites. There's been a new water quality index, the VPAR, developed, which Barbara will present on it tomorrow, I think, which relates directly to ecological impacts and considers chronic effects of light stress. There's been also ecologically relevant indicators, which has been established for seagrass and light thresholds, and desired states have been also established, which are relevant to target setting. Results additionally provide assurance for existing load targets by comparing scenarios with proposed thresholds. Changes in ratio of the blue versus green light has also been identified, which are assisting to identify the causes of aquatic light reduction, whether if it's dredging or sediment related, or if it's just cloud cover. And finally, cumulative impacts of multiple stressors have been also assessed through this research. Moving towards the sediment delivery to the end of catchment, we know more about the most important sediment characteristics for ecosystems and how and when they are transported, and this is going to help to target catchment management efforts. We've seen that using tracing techniques, the most damaging sediment sources have been identified, which are those fine organic-rich sediment that has the ability to travel farthest in the Great Barrier Reef and has the capacity to release dissolved nutrients and influence turbidity. Results have also identified that plume sediment is dominated by subsurface erosion sources. And they have measured the release of dissolved inorganic nitrogen from sediment-laden plumes, confirming that bioavailable particulate nitrogen is an important source of nutrients, as Alex just presented. Going upwards in the catchment, there's been a lot of research on reducing catchment sources of sediments. So we know that the most cost-effective management options for sediment reduction can vary between catchments and landscapes. Foundational knowledge was generated to accelerate sediment reductions in high-priority areas. There's been some of the projects have developed a gully characterization framework for cost-effective prioritization of effort. There's been as well some of the most vulnerable characteristics have been highlighted, including the rate of erosion, the position in the landscape, and the opportunities for efficiencies. As we saw before, if some of the gullies can be clustered, that would probably end up in a more efficient project. Results have also assessed the diversity of gully forms and confirmed that a diverse array of management interventions will be required for their effective treatment. And it has also been identified that 30% of the gully sediment yield in the BBB, Normandy, and Fitzroy is coming from between 1.5 to 3.5% of the mapped gully population of 26,000 gullies, which hopefully should make our work a bit more feasible, not more cheap, but more feasible. Finally, I'm finishing now with, I have one more slide on this, sorry. There's been also investigations of the most cost-effective remediation techniques at various scales. So we've seen that all those large-scale engineering solutions have proven to be very successful in reducing sediment losses from the large active alluvial gullies, with up to 98% of reduction on those sediment yields. We've heard several times today that the emphasis needs some emphasis on the need to treat the gully itself, plus the surrounding catchment area. At smaller scales, though, porous check dams and stock exclusion fencing also appear to have an important impact on the amount of vegetation that stabilizes the gully's floors. And the reduction of livestock grazing pressures within and around gullies could be an important method for hillside gully erosion control. Costs, again, vary between locations and methods, and everyone seems to agree that there is a need, an urgent need, for the application of a standard cost-effective metric across investment programs. And now to finish, some examples of how all this research on the sediment topic are informing or have informed already management. First of all, through a direct reduction in the end-of-catchment fine sediment loads associated with the proposed management practices, such as through the stream bank and gully remediation projects. There's also potential reduction in ecosystem impacts expected from the improved understanding of those damaging sediment characteristics, nutrients bioavailability, and light limitations in coastal ecosystems, as well as the improved water quality monitoring tools and protocols, and the application of new indicators of ecosystem health within monitoring programs. All this research is already informing investments in improved water quality, such as the Reef Trust Partnership and the Burdekin Major Integrated Project, in terms of management options, site selection and prioritization, monitoring and evaluation techniques, and understanding the variability in treatment options and cost effectiveness. Research has also informed and is informing the review of the Reef 2050 Water Quality Improvement Plan, sediment reduction targets. Gosh, that was a long sentence. And it has the potential to significantly contribute towards foundational documents, such as the Scientific Consensus Statement and the Great Barrier Reef Outlook Report. And it's all from me. Thank you.